Perfect. Actually, Yogi, could you put the link in the chat so that people can follow along? Hopefully that's a yes. If not, let me know.
Yes.
Oh, perfect. Thank you very much. Okay. Great. So let's get started real quick.
Says it needs access.
Oh, shoot. Okay. Yogi, do you have permissions to give access or should I do that?
I did it.
Okay, perfect. Cool. All right, so let's jump into this and yeah, get started. So hopefully you guys were all able to see the Discord message about creating a Tinkercad account. If not, now is the perfect time. It really doesn't take too long. So just go to the website tinkercad.com and then click sign up and follow all the instructions. And yeah, we'll be doing some exercises for the LCD screens with Tinkercad tonight, just because unfortunately the order that we submitted didn't end up having everything fully soldered already like we ordered it to. So we'll figure that out and we'll get that done at the Makerspace on Friday. But in the meantime, you can learn everything you need to know on Tinkercad virtually. So yeah, let's get into what LCD screens are. Oh, hold on. Are we recording right now? Yeah, we are. Okay, great. So an LCD screen is a liquid crystal display, and it's just a flat panel display that uses light modulating properties of liquid crystals. So that's just a type of material combined with polarizers. And polarizers are essentially like filters for light. So depending on the angle, you can get different colors. And LCD screens use backlights or reflectors to produce their images. So they actually don't produce light themselves directly. There's a backlight at the back that we're going to see how to turn on, and that's how they operate. They're also made up of millions of pixels. So each pixel is made up of 3 subpixels, and they're RGB, so red, green, and blue. And the color combinations dictate what colors they are for screens that have color. Okay, so then let's get into different types of LCDs. So there's something called a character LCD, which is what we'll be working with. And these are what came in your HAcK boxes. So hopefully you have these with you and are looking at them. Unfortunately, we're not going to be able to wire anything on them today, just because if you look carefully, you should have your LCD plus header pins that are not yet soldered onto them, but they will be, and it'll look like this. As you can see, there's some solder bumps right here that indicate that you'll be able to plug them straight into your breadboard. But yeah, these are character LCDs, and what they mean is that you can just write a bunch of characters, like see they have peace love code, which is just words. And then you can see that as a function of character LCDs, they also have custom characters like this peace sign or this heart. So you can also use those as well. And then for graphical LCDs, these we won't be working with. They're a little bit more expensive, and that's because they're designed to have more complicated images on them. So you can see this person was able to create the office logo on that, but that's just an example of a more complicated LCD that you can use. This we don't have to get into too much detail. You don't need to know too much about this. It's just the data sheet of what each of the pins on an LCD do. An LCD has 16 pins and they're all arranged in a line. You can kind of see these here. Actually, there's 1, 2, 3, 4, 5, blah, 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 up to 16. Essentially, all you need to know is that there's a ground and power supply. Then you can have an adjustable supply voltage. This will be connected to a potentiometer if you do connect it to a potentiometer, which we'll practice today, and can change the brightness of the screen. Then you have a few pins. This one we won't be using. That one just changes read to write mode, which we won't be worrying about, so you don't have to worry about that. And then all of these are basically just a bunch of signal pins that you don't need to really worry too much about exactly what they do. But yes, you're going to need all of them for connecting to the Arduino that we'll be using on Tinkercad. Now to get into soldering your LCD, we will probably be doing this for you. So you're probably not going to have to worry about this at the Makerspace, but just wanted to give you a heads up about how you would do this. It's very simple. So if you've never soldered before, how it works is you would just take these header pins, they're called header pins, and they're just like breakable. And you can see how these are holes inside of your LCD component. So these header pins these little things are going to stick into these holes. And as you can see on the next slide, you can just have them placed beautifully in. You're going to want the header pins to be as straight as possible, so not at an angle, and this will make it the easiest to plug into something like a breadboard. And then you would take a soldering iron, which is just a very hot pen essentially, and a little bit of solder, which is just a wire. And then you heat up the wire so that it melts and it solidifies around the header pin right on top of your LCD. So that just keeps it from moving around and makes everything connected via metal so that you have your connections, and it's just like wiring something up, but with solder. So now we'll get into how to set up your Tinkercad. So hopefully by now everyone's gotten their Tinkercad account set up. What you're going to do is from your dashboard, you see this is like an example of my dashboard. You're going to click this button that says circuits. Essentially, Tinkercad has like a bunch of different options, and so circuits is one of them. That's the one we'll be using today. Then you can click create new circuit, which is this green button right here. And once you do that, you should be able to see this is just a segment of your workspace, but it's essentially a giant screen that'll be mostly blank and gray. That's your workspace to put electrical components on to create your circuit. So what you're first going to do before you do anything else is start typing in this search box on the right hand side. So hopefully you all see that. Let me actually stop right now because that was kind of a lot. Does everybody see the search bar so far? Yes or no in the chat, maybe? Do you see the search bar? Yes, 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 yes. Okay, cool. Great. All right. So hopefully you do. Then what you're going to want to do is type in your different components, and you can drag and drop them into your space. So what I've done here is I just typed Arduino, and then what I would do is I would click on it, drag it, and put it into this sort of like modeling space essentially. So you're going to need a few different components. It's pretty simple. You're going to need this one, which is your Arduino Uno. It's the only one that pops up when you write Arduino, but it's called the Arduino Uno R3. And then you're going to want to pick up an LCD, which is your liquid crystal display. That one we can just use the 16:2 one. 16:2 is just referring to how many characters are on it. And then potentiometer, you can just type in potentiometer. You should be able to drag and drop the potentiometer that you're looking for. A breadboard, you can use like the small breadboard. It doesn't really matter which one. And a resistor. Today we're going to be using 200 ohms. So that's your list of parts. And hopefully you all have the link to the slide so you can kind of work on this as I keep going, but I just want to be conscious of time. So I'm just going to move on for now. But then the other important thing that you're going to want to look at is up at the top, there's going to be, for me, it started out as green. I'm not sure what color will start out for you, but probably green. And you can choose which color you want. And this is just your wire. So essentially you have an unlimited supply of wire on Tinkercad. You can click whatever color you want, depending on the convention. And then you can click on a point, drag to, or not, I guess technically you click and then you move your mouse and hopefully your wire should follow you. So Yogi will be doing a demo of walking you through the Tinkercad process in a bit, I believe. But yeah, that's just the basics of how to get a wire set up. And then the last thing you'll need to know for Tinkercad before I pass it off to Yogi is on the right-hand side, you should see a button called code, and it has this little symbol next to it. And that's going to be the place that you're able to program your Arduino code, similar to an Arduino IDE if you were using a physical Arduino. So today we're going to just be using the Tinkercad one. But if you click on code, you should see a bunch of Scratch blocks, and we have not been using Scratch recently, so you may want to change this. So what you'll do is you'll click blocks. So there's this drop down that you see that says blocks on it. And what you're going to want to do is select text. So that'll just allow you to edit code almost exactly as if you were in the Arduino IDE. And yeah, you can just paste and edit your code here as if you were there. So I believe, yeah, that's it for me. And then Yogi, do you want to take it over and do a quick walkthrough of how we're going to set up our LCDs?
Yeah, sure.
Sweet. Okay, so I'm going to stop sharing.
Let me share. There it is. Can you see?
Yeah.
Okay. Let's start with more. So, let me do this. As Kendall said, we are going to search like Arduino. So, get Arduino. That's good. LCD. Wait, LCD. Let's do like this. Potential. This. Okay. Where is it? Wait, where did it go? Oh, there it is. Let's see. Let's just, so let's start with like, so we are going to connect like the, actually we need to turn this. Let's turn this. Actually. So we are going to connect the 5 volts first. So this to here.
And yeah, if you want your wire to kind of do that snake pattern, so everything's organized, you can just click on the points that you want it to curve, and it should have a bend in it.
How did you rotate the
It's
parts?
this one.
Oh, okay, cool.
Oh, you can see like one of those.
So you would just click on whatever part you want to rotate and then click on the button to rotate it.
Yeah. And so we will start by connecting 15 and 16. So 15 is this red. This one is this, and it's, you said 200, right?
Yeah, 200, around 200 is good. You can play around with it a little bit, but
Yeah.
200 is what I used.
Okay. And then we should connect the potentiometer, I think. Potentiometer is like middle goes to the V node, which is the third pin. And the first one goes to ground, actually. The first one goes to the ground. And the second one goes to voltage. So if you turn on, it should turn on. Turn this. Oh, I haven't connected the potentiometer. So we connect the potentiometer like this. Actually. And this one to the so it shows you. It shows the screen.
So in real life, it would kind of have a varying brightness as you turn the potentiometer.
Yeah, in the actual one, it has like different. Like when you turn the pool, it's not like it's like too bright. But in this case, it's like you can see it. Then you connect the I think we are not going to use the RW, which is the ground. So, and RS goes to orange. Let's do brown. RS goes to the 7. And the E goes to 8. And then this this one goes to 12. Goes to and then let's do actual light. This one goes to actually yeah. So this goes to 9.
Yeah, so you can kind of see how those 4 wires all stay next to each other on the Arduino and on the LCD, so they kind of snake over. And what's cool about that is which ones they are doesn't really matter. It's kind of arbitrarily defined. So we just have it set up like this so the wires don't have to cross and it's really neatly organized.
Yeah. So this should turn on right now. Because so let's, if you are like set up, can I get like yes? Like if you're like good to go. Yes, so thumbs up. Either works. Are we getting any thumbs up? I can't see.
Let's see. Are there any thumbs up? Okay, 1 thumbs up. That's good. Thank you, Ethan. Is anybody, here's a better question. Is anybody confused so far? Type in the chat.
Yeah.
Type in the chat, I'm confused. Do it. Do it now.
It's going a little too quick, so I'm just like trying to work out the wires. Well, I think it's pretty
Yeah.
straightforward.
It is
It's
really
like-
fast, yeah.
It's like we had to go through a lot.
Yeah, it's a lot. And getting set up with Tinkercad is a lot too.
Yeah.
But yeah, I just wanted to clarify real quick. So kind of the way to think about it is you look at the LCD. 1 is the left-hand side as we're looking at it now, and then 16, which is the last pin, is the right-hand side. And so if you look at it, you have ground, then power that's powering the LCD. And then you have the pin that is the 3rd pin, which is connected to the potentiometer that tells it how bright to be. Right, it varies. Then you have the 4th pin, which is connected to pin 7. Yogi, do you remember what that one does?
Which one?
Pin 4 on the LCD, which is connected to pin 7 on the Arduino.
I think it does the read and write, right?
I want to say that might be pin 5. Hold on, I have it on the slides. Let me check real quick.
Pin 5 is enable. Actually, I'm not sure. I think it's on the thing.
Yeah, let me pull it up. Okay, so pin 4, which is the 4th one on the LCD, that's a signal for selecting resistors. So I guess 1 is read and write and 0 is just for write. So you're right about that. And then 5 is the one that we won't be using. So we're connecting
Yeah.
it to ground. But that one has 2 different modes. So it has a read mode and a write mode. So essentially, you don't really need to know exactly the specifics of what it's doing. But then the next 4 pins we don't even use, so you don't have to worry about those. They're not connected to anything. And then you see the next 4 pins after that. Those are just the snake ones. So they kind of like follow each other into the Arduino. And lastly, you have the power and ground at the end, and those are for the backlight on the LCD. So that's basically what's reflecting the light to get you something that you can see.
Also, technically, you can use like these 4 ones. So what it does is like it increase the speed that it like displays.
Mhm.
So in our case, we don't need that, and we have to like save like other spaces. So
Yeah, and then 200 is a good amount for the resistance. That just tells it how much to like interfere with the current, so it's not overpowered and fried. But actually, I think the LCD screens that you guys will have in person won't need the resistor because they have a built-in one. So in this case, just the LCDs on Tinkercad don't have the built-in resistor, so that's why we're using it today. Yeah, the potentiometer is on the left-hand side, so that's the blue circle. And that one has 3 different wires coming out of it. Ground and power are the ones on the outside. That's just powering the potentiometer. And then the yellow one in the middle is connected to pin 3 on the LCD. So that's the signal pin that's telling the LCD how much brightness to give it. Max resistance. In terms of the potentiometer? Oh, interesting. I don't know what the internal resistance in the potentiometer is. Do you know offhand, Yogi?
I don't know. There are like, it depends on the potentiometer also. There are like potentiometers that can go like 10K. I'm not sure, like usually it is like mentioned or something. I'm not sure how to like check it.
1K? Okay, cool. Yeah, so okay, how's everyone feeling now? Thumbs up if you're like, yes, this is great. We're on track.
Also, we
Hi,
don't
Sute,
need the
that's great.
resistor.
Oh, what are you gonna say, Yogi?
We don't need the resistor in the actual LCD.
Yeah, because we have LCDs with the internal resistor built in.
Yeah.
So yeah, we're just going to use this for demo purposes on Tinkercad.
Yeah. So we can move forward. I think we can move, right?
Yeah, that seems good.
Yeah. So we went over to. Oh, now we can test out the. So if you get the Arduino, like if you check the. Do this. Go to the. So if you go to this, like Arduino, you have to go to examples, liquid crystals, hello world, and copy that thing, and you can paste it to the Arduino, like the Tinkercad. So I'm gonna do that. Okay. Let's do this. I'm gonna copy examples. Else, where is liquid crystal? Okay. And the hello world. So this is all like comments. We don't really need it. So we only need this part from the this one. And I'm gonna go back to thing. Specs. Paste it. And then in the slides, it says like change this to like, it's like 7, 8, 9, 10. So you have to change these to like 7, 8, 9, 10, 11, 12.
Mhm. And that's because the liquid crystal library is built into Arduino. So you see how it says hashtag include liquid crystal.h. So it already has preset settings for its examples for which pins you're going to be connecting like these last 4 pins to. But in this case, we rearranged it so you can just redefine them based on how we're doing it. And it's kind of nice because it's just incremental. So it's 7, 8, 9, 10, 11, 12.
So if we start the simulation, should say this.
Yeah. And it's doing that. It's like changing the numbers because it's being instructed to every second print the next number. So see how it's going LCD.print, and then the milliseconds it's been going divided by 1,000. So that's just the seconds it's been going for. And if you were to reset it, it would start again.
Yeah. Because millis is like, unlike delay, you can use millis because when you use delay, it stops, right? If you use millis, it's like continually counting when the thing starts. So you can use millis instead of delay, but it is hard to use.
Mm-hmm. And then, yeah, you can leave the LCD.begin line just as is. So hopefully it should work if all you do is just change the pins at the top. And yeah, I don't think you need to change anything else.
Yeah.
So yeah, hopefully that makes somewhat sense. And what we can do is go into breakout rooms and kind of troubleshoot for you guys, because I know that was very fast. So oh, you got it working? That's awesome. Great.
Nice.
Cool. But yeah, for any of you who have not yet, don't worry about it, because that was like speed of light fast. So we can go into breakout rooms really fast. And then Yogi, what time did you want to come back to go over custom characters?
I think like we'll give like 10 minutes probably.
Okay, yeah, hopefully that's enough time. We can come back at 8:50 and then go over custom characters, and then we can go back into breakout rooms and work on that. Okay, cool. Ming, would you mind opening the breakout